Hi, Ronan here, and welcome to a tutorial on calculations. I really wanted to get kind of the basics of two particular concepts, molarities and percentages in solutions across to you in this tutorial, so I hope you'll find it helpful. So what we're going to do is run this tutorial as if we have an example problem. So what you're in charge of today is making up a certain buffer. You have to make up a buffer of 250 mils containing 10 millimolar NaCl and 5% glucose. So note the volume and note the amount of each salt, the concentration that you require. So we have to first think of molecular weights. Molecular weights are the components, atomic masses added together. So Na and Cl would give you 58.44. Glucose 180. We can get these more regularly from the carton of the salt that we use in the lab. It's written on the side with MW beside it. So what does the MW tell us? Well, we can gain a lot of information from this number. We can realize that it means 58.44 grams of NaCl in a litre is 1 molar NaCl. And likewise, if we have 180 grams of glucose per litre, it's equivalent to 1 molar of glucose. So this number really tells us how much of the salt is required to get a 1 molar solution. So if we take NaCl's molecular weight, 58.44, and fit it into the equation that we've just discussed, 1 molar NaCl will be equal to 58.44 grams in a litre. So we have to work out 10 millimolar in this kind of problem that we have in the tutorial. So let's go to millimolar first. So 1 millimolar will be 58.44 milligrams per litre. So all we've done here, as you see in red, was put M on each side to get milligrams and millimolar. So if we have 58.44 milligrams in a litre, it's a lot less salt, and that's why it's 1,000 times less concentrated in regards to molarity. So when we multiply by 10, because we want 10 millimolar, we get 584.4 milligrams per litre. Now you got to remember, this is all per litre. The volume we have to calculate for is 250 mils. So a litre is made up of 1,000 mils. So therefore, if we divide it by 4, we should get it to 250 mil. That's exactly what I've done here. 10 millimolar is equal to 146.1 milligrams per 250 mils. So this tells me how much salt I have to weigh out. A lot of people prefer to work in grams, and that's totally understandable because a lot of the weighing scales are set to grams. So we can convert this easily by just dividing by 1,000 to get 0.1461 grams in 250 mils. So now we know how much salt we're going to have to weigh out. Let's go to the other solution, glucose. So here's a bit different, no molarities, and actually we don't need molecular weights. The equation 1% is equal to 1 grams in 100 mil. That's applicable to any salt, okay? So in this case it's glucose, but it could be any solution. So if 1% is 1 gram in 100, well, we want 5% glucose. So 5% will be 5 grams in 100. We're not just looking at 100 mils, remember, it's 250 mils, so we have to calculate accordingly. And the same thing, if it's 5 grams in 100, it's 12.5 grams in 250 mils. So we can easily work out the amounts of salts that we have to weigh out. And in this case, it was 0.1461 grams of NaCl and 12.5 grams of glucose. Once we know the amount of salts, we now have to work out the method for how we're going to make up the buffer. And this method is extremely important if you're going to have a buffer that is exactly what it says on the label. So we're going to be looking in detail at this method in lectures and in labs during the semester and even throughout the year. So two equations I'd really like you to take home from this would be 1 molar equals the molecular weight in grams per litre. So 1 molar NaCl was 58.44 grams per litre. And the second equation, 1% equals 1 gram in 100 mils. I hope you found this helpful. These equations will give you a starting point to work with. Also, I know other people will have their own ways of doing equations, and that's fine. If they work for you. But I just wanted to share with you two ways I thought might help you in your calculation studies. Okay? Best of luck.